Okay, now that we know about how to just tell how many significant figures a number has, we need to see how these significant figures are carried through in mathematical operations. So the first thing we're going to look at is addition and subtraction. And for all of these operations, the rule is basically that the number of sig figs in the answer can only be as many as the number that goes into the calculation with the fewest. Or in other words, your answer can only be as accurate as your least accurate measurement going into the calculation. So for addition and subtraction, the way I like to think of this is you should keep the smallest number of decimal places. And so if you're subtracting two numbers, you need to be careful because sometimes uh, that can reduce your number of sig figs overall. So for these two numbers, the first number has 3 decimal places and the second number has 2. So I'm going to draw a line here that lets me know where I'm going to cut off the answer. So the answer to this is 0.947 grams. And so when we round this off, we need to round it off to 2 decimal places where that line is. So this would be 0.95 grams. For multiplication and division, it's basically the same idea, except instead of keeping track of decimal places, we're keeping track of the smallest number of sig figs overall. So we multiply these three numbers together, and don't forget about the units. And the answer to this, if you put this in your calculator, is going to be 2.3859 cubic centimeters. And so what I like to do here is, count the number of sig figs in each of the numbers going into the calculation. So this number has 3 sig figs. Second measurement has 4 sig figs. And the third one also has 3 sig figs. So your answer can have no more than 3 significant figures. So I'm going to draw a line here, and that tells me that that's where I'm going to round that off. If you were going to use that in another calculation, you would just keep all the digits in your calculator. But I like to draw a little line to let me know where I'm going to round that off. So in that case, I would round this to 2.39 cubic centimeters. And now when we do combined operations, you need to follow the order of operations. And what I like to do normally with this is do it stepwise. So you could just punch this all into your calculator right away and get one answer. But if you've got addition and subtraction combined with multiplication and division, then I like to do it in 2 steps. So you'll notice these are the same calculations, and you might notice that this is a density calculation, grams over cubic centimeters, or mass divided by volume. So the first number, we've got the calculation up top, right? We would take that 0.947 grams and remember that we've only got 2 decimal places that we can keep for that measurement. And then on the bottom, we've got the 2.3859 cubic centimeters, and I'm going to draw a line over the 8 again to let us know that we've only got 3 significant figures in that answer. So when you do this calculation, right, keep track of both the bottom and the top, the numerator and the denominator. And when we carry this out, we get 0.39749 grams per cubic centimeter. And so on the top, we've only got 2 significant figures. On the bottom, we've got 3, so our answer can only have as many as 2 significant figures. So I'm going to draw a line over the 9 there. So when we get our final answer, we've got to round it off to 2 significant figures. So this would be 0.40 grams per cubic centimeter.